about quadratic equations today, okay? And if I have a little bit of time, I'll also show how to divide polynomials. That's a couple things that I didn't cover. We did went through factoring, right? So let's say I have a quadratic equation just like this one here. And if I ask you to factor, how would you do it this one? Yes?
The factors of 16, 1, 16, 2, and 8,
Yes?
and 3 and 4.
Yeah, this is the product, and this is the sum, right? So product of 16, 1 times 16 is 1. I have 2 times 8, and I also have 4 times 4. Right? The key thing is that here, the sum needs to be 10. So we can see right away it's 2 and 4. So it's easy to factor that. So that would be the two binomials that represent this quadratic equation. Not quadratic equation yet. Right now, it is an expression, right? Because there is no equal sign, and nothing was here, so now I have an equal sign and I have equal to 0, and now this is an equation. And it is difficult to solve. Solve meaning finding the value of x, but when I reduce the degree by factoring, then it becomes easier, right? To find the value of x that is going to make this here equal to 0, okay? So what is the value of x now? What is the value of x?
Negative 2 and negative 8.
Exactly. From here we see negative 2, and here we see that's going to be negative 8. So what does that really mean? Well, what is the graph of a quadratic equation? What would be the graph of a quadratic equation? If I have y equals x squared plus 10x plus 16, I want to graph that. If I want to graph that, how's that going to look like? Yes, a U shape, right? That's what we call that a parabola, right? Now, when I make this y equal to 0, and this is exactly what I had here, what is that I'm really finding? The x-intercept. Thank you. So now, if I just enter here negative 2 and negative 8, I have 2 intercepts. So this parabola is going to look somewhat like this, right? And here, what is that called?
The y-intercept.
The y-intercept. Can I find the y-intercept here? Where is the y-intercept? When x is 0. Very, very good. So when I set x equal to 0 here, y is equal to 16. So I have here my 16. So easily we can see that, right? Now, what happens if it's this U shape here, curve, start going up and going up, going up? What's going to happen? At some point, this U shape, this parabola is going to touch here only in one point, right? When is that going to happen?
When there's only one solution for x.
Only one solution for x, right? So here, you see there are 2 solutions, right? Is there a way, if I have only one solution, that means an example would be x plus 2 times x plus 2, right? So here, if I have a polynomial that looks like this x is going to be only x equal to negative 2, so there will be only one solution. And this is what we call a complete square, right? A complete square. This is x plus 2 squared, and where's that equal to? It's going to be equal to, what would be the quadratic equation look like? It's going to be what? 2x squared and
Plus 4x.
4x plus 4, right? So that is a complete square. If I were to solve this one here, for instance, I would have only one point, only one solution. All right? Is that okay? So this is the first way to solve a quadratic equation. The other way would be if I give you the quadratic formula, okay? The quadratic formula is x negative b plus or minus square root of b squared minus 4ac 2a. So this is the quadratic formula. And this formula you can use to calculate any quadratic equation, right? This here happens that I can factor this one, but sometimes it's not going to be possible to factor. Not all quadratic equations, right, are factorable, right? Not all quadratic are going to be factored. An example would be this one here. Let's say I have 3x squared plus 5x minus 1 equal to 0. Can I factor that one? No, not really. I cannot factor that equation. It's not possible, right? You see here, what two numbers, the product is going to be equal to -1, and the sum is going to be equal to 5. And in addition, I have a 3 here that's not, it's not going to be like this, okay? Just x1 times x1. It's going to give me x squared, not 3x. So in this case, we can use this formula, okay? Let's say, and this is the standard form of the quadratic equation. That's the standard form, so I just need to plug in the numbers. And that's not very difficult, okay? So let's do it. X equal, what is b here? B is what? What is the value of b? 5. So I have here a negative b, right? So I'm going to put -5, plus or minus square root of 25 minus 4 times a is 3, times c is -1, okay? All right? And here I have 2 times a is 3. Is that okay? So I plug in b squared, that is 5 squared, then 4 times a, that is 3, and then times c, that is -1. I just need to solve this now. All right? So 4 times 3 is 12, negative with negative is positive, so 25 plus 12 is going to be 37. So here I have x equals -5 plus or minus square root of 37 divided by 6. So you notice that I have plus and minus, so that means I have two solutions. Do you see that? Two solutions. Okay. Now let's look at this number here. Let's solve this one now here. Let's use this one. Okay, let's use the formula to solve this one and see what happens. Okay? So can I erase this here? Is this okay? Just to save space. Can I erase? Oh, maybe I leave it so we can compare. But let's solve this one here now. I'm going to write that here. X squared plus 4x plus 4 equal to 0. And then I'm going to write x equals, what is negative b? Negative b is going to be -4 plus or minus the square root of b squared is going to be 16 minus 4 times a, that is 1, times what? C, that is 4. And here is going to be 2 times a, that is 1, so it's just 2 times, just 2. Now, notice here that I have 4 times 4 is 16. 16 minus 16 is equal to? 0. So, this term here goes away. You notice that? If this term goes away, this plus or minus here now is irrelevant. So, how many solutions I'm going to have? Only one. Only one. So, So when this here is a positive number, we have two solutions, right? That's the conclusion we're getting, right? When this here is a positive number, we have two solutions. When this here is equal to 0, we have one solution, and that relies on the perfect and complete square here, right? And what happens when it's negative?
It's no solution.
Then it's going to be a complex number, right? Remember, square root of a negative number, negative 4 for instance, we can split this into a negative 1 times square root of 4. Now, this here makes things difficult, right? Because the square root of a negative number is not really something that we can figure out, right? But we call this here what? An imaginary number. And once we do that, we can resolve this. So square root of 4 is 2, and then 2i, this is the imaginary number, right? So when we have a negative, but let's think about what that means in terms of graphing. So there are two situations here right now that we understand. One is when we have two solutions, right? Two intercepts. We have a situation when we have one intercept, and that is when we have a complete square. Now, when the parabola is above the x-axis, that is the situation that we have this term here, a negative number. So I want you to visualize that. When you try to solve this, and you figure out that, oh, there is a negative number here, so you can think that what's really happening is that this graph has moved up, okay? It's above the x-axis. It's not touching. So there is no real solution, right? We have here two real solutions. Here we have one, and here we don't have any. We have a complex solution, a complex number, all right? Okay, so I think I covered method 1 using factoring. I'm covering method 2 using this formula, right? Now I'm going to introduce a new method called completing the square, okay? So let me write another example here. Let's say now I have this equation here. I have x squared plus 6x plus 1 equal to 0. And I look at this here and say, oh, that's not factorable. I cannot use it, right? And I could use the formula, but I just forgot the formula, okay? So there is a third method. That's what I'm going to use now. The third method is called completing the square, okay? Completing the square. Now, let's just have here this. This is very helpful if I do it this way. Let's say I have here x, right, my variable, and then I have here a number. I put in here r, okay? So let's do it. If I do this multiplication, I'm going to find that it's going to be x squared plus 2 times r x plus r squared, okay? It's just like this one here. You see, this is 2. 2 times 2 is 4. And then 2 squared is 4, right? This is the formula. This is the formula when I'm doing the square of a binomial, okay? Could be any number. So when I look at this here, and I put this right here underneath this, 6x plus 1 equal to 0, right? When I do this, what is that I notice is that in order to have a complete square, this term here is 2 times r. R is this number, right? That I'm looking for, right? So, but here I have r squared. So what would be the value of R for this here, for 6? 3, right? So this here, so 2R is equal to 6, R is 3. So if R is 3, what I really should have here is what? 9. Do I have 9? No, I don't have 9, but I can do magic, right? Remember, Eugene can make magic? So I'm going to do magic. I have the power to do that, right? As long as I follow the rules. So I'm going to add 9 on this side, but if I do that, I need to add 9 to the other side, right? To be fair, right? If I add 9 to the left, I need to add 9 to the right, okay? So the beauty now is that I can reduce this degree from 2 to 1 by now just writing this format, okay? It's going to be x plus 3 squared plus 1 equals to 9. So that makes things easier, isn't it? So I move now this 1 to this side. It's going to be x plus 3 squared equals 8. And I want to find the value of 3, of x here, right? This is what I'm looking for. But I have a square. If I find the square root on both sides, right? So things become much easier. So I'm going to do that. Plus 3 equals plus or minus square root of 8. Plus or minus. You see? You have to remember plus or minus is this here, right? This plus or minus. Right? You see that? So, and so what is the value of x? X is going to be x equals negative 3 plus or minus square root of 8. There you go. It's that easy, okay? If I want to apply that formula, I would find the same thing, and I suggest you try to do it, okay? Just try to do that. Okay. Any questions? Is that okay? Now, a good exercise would be if you, at home, try to solve this equation here, okay? A x squared plus bx plus c equal to 0. If you try to solve this one by completing the square, okay, what would be the first thing you need to do here? Look, I need to have 1 here, right? How can I have 1 here? What is the first thing I need to do? If I want to, instead of a, this is a general form, right? This is the standard form of a quadratic equation. If I want to have 1 here, what should I do? Divide everything by a. You guys want to do that? Let's do that. Let's divide by a and look what happens. So now, from this point, you need to do the same thing that I did here, okay? Find the value of r. What is the value of r? Is this number here, what? Is this number here, how did I find the value of r here? How did I find the value of r here? What have I done to 6? Divide by 2. So you get this guy here, divide by 2, and you have what? R, right? So you could do that, and then that gives me a hint of what r squared is going to be. So it's going to be this term, b over 2a, that's r. So r squared is going to be what? R squared is going to be b squared divided by 4a squared. Well, I don't want to do everything. I want you guys to try to continue. I just give you the hints so you follow the same steps. And I promise you that the solution that you're gonna find here is exactly this form. Okay? All right. So I'm going to stop here now, and I'm going to continue with the division of polynomials now. Let's go over division, long division of polynomials, okay? That's the last topic I'm going to cover today. So let's say I have 4x, 4 plus 2x cubed plus x squared minus x minus 10 divided by x plus 2. Okay, let's say I want to divide that. So I'm dividing here a polynomial of degree 4 by a binomial, okay, degree 1. Basically what I'm doing when I do this division is reducing the degree here, right? You guys remember, if I have x to the 4 divided by x, this is going to be x cubed, right? That's what's going to happen. So the answer here is going to be another polynomial of degree 3. Okay? So do you guys remember how to divide? Let's say I have 3 and I want to divide 371. How that works?
3 goes into 3 one time.
Figure, okay, 1 times 3 is 3, then I subtract, right? 0, I bring 7 down. How many times 7 goes in 3?
Twice.
2, twice, so they make 6, minus 1, and then 1, and then comes 11. And then how many times here? 3, and then it's going to be 9, and 2 is the remainder, right? Now, the remainder, I can say now that I have here 371 divided by 3 is going to be 1, 2, 3, plus the remainder, right? That is 2 over 3, right? That's the way we, can represent that. Is that okay? Everybody fine with that? So let's do the same thing here. Log division is the same as that, just that now we are dealing with, a okay. So the key here is to look at the first term. Look at the first term here on the polynomial. 4x to the 4, right? And I have an x here. Now, what term should I put here that multiply times x is going to give me 4x to the 4? 4x cubed. Very good. 4x cubed. This is really fun to do. Don't you guys like that? I love doing this, So, when I multiply this term times this one, I'm going to have exactly 4x4. Right? Now, I need to remember I'm multiplying this times the binomial, so I cannot forget to multiply 2 times that. So 2 times that is going to be 8x cubed. And you see that lines up with this other guy here, right? The same. Now, what I'm doing here, I'm taking away, right? I'm taking away, I need to do the same here, but here, because this is an expression, I cannot just put the negative here, I need to put the parentheses and the negative, okay? That's very important. A lot of students miss this here, okay? They miss the parentheses, and they forget that the negative has to be distributed there. So when I do that, this is going to become negative, it's going to cancel this term, this is going to become negative with positive there, I'm going to have 6x cubed. Then I bring the next guy down, x squared. So now it's the same thing. What term should I add here that times x is going to give me negative 6x cubed?
Negative 6x squared.
Negative 6x squared. Beautiful. So now I have here negative 6x cubed. and then times 2 again is going to be negative 12x squared, okay? And again, parentheses and the negative, you cannot forget that, okay? Parentheses and the negative. So distributed the negative, this is going to be positive, it's going to cancel, this is going to be positive, it's going to be, I'm going to be adding that guy, and then bring x down. Again, what is the next term here? Now? 13x. 13x. Why? Because 13x times x is going to be 13x squared. Okay? So let's then do that. 13x squared. Then, cannot forget the 2. Times 2 is going to be 26x. Do not forget the parentheses and the negative goes away. This going to cancel, this is going to be negative. Now I have negative 27x, and then I bring my last term here, the negative 10. Again, the last chance for you guys. What is the term that I'm going to put here that times x is going to give me negative 27x? Huh? Negative 27, right? Negative 27. Negative 27 times x is negative 27x times 2 is going to be negative 54. Now parentheses, negative, and there go. This is going to be positive, it's going to cancel. This is going to be positive. I'm going to have here 44. So this is the answer, right? Right like this 1, 2, 3. Remember that 1, 2, 3? This is the answer. But I need now to add my remainder here. There's going to be plus 44 divided by what? Divided by this binomial. You see, x plus 2. So this here is the solution of the division. This is the long division of polynomials. And basically, this is the last topic that I needed to cover, okay, for this class. Thank you.